In this presentation or number system, we are going to talk about the representation of rational numbers on number line when the rational number they are given in the form p by q. And second, we are going to discuss the successive magnification, that is when the rational number they are given in the decimal form. So we start this presentation with the representation of rational numbers of the form p by q on the number line. So we know from the definition of rational number that a number in the form of p by q, where this p it is called numerator, it is an integer, and q it is called denominator and it is a non-zero integer. So we are saying that the possible values of q that we have, the denominator of a rational number, we are saying it is 1 minus 1, 2 minus 2, 3 minus 3 and so on. So corresponding to different denominators, we are going to show that we can represent every rational number on the number line. So first of all, we consider the value of q is equal to 1. That is all those rational numbers with the denominator 1. So if denominator is 1, then the rational number will become p by 1. That is equal to p, and p we know it is an integer. So if p is an integer, it means that we are talking about the number line that we have already discussed in our previous lectures, that we can represent these integers on the number line in this form. All these numbers 0, 1, 2, 3, 4, and on the left hand side we have 0, minus 1, minus 2, minus 4 and so on. So these are the rational numbers with the denominator 1. So we are saying that we can represent all rational numbers with denominator 1 on the number line. Now next case we have is, if we consider the denominator of the rational number to be 2. So we are saying that each rational number with 2 as its denominator can be represented by some point on the number line. So to represent all the rational numbers with denominator 2, first of all we are going to draw a line xy. We are talking about this situation. We are saying we have drawn a line xy. Now on this point, on this line, we are going to take a point O. Suppose we are saying that this is the point O we are talking about, and this point O it represents the number 0. This is same as we were discussing in the case of the representation of integers. Now by taking a fixed length called the unit length, we are going to mark a point A such that the length OA is equal to 1 unit. We are saying we are going to mark a point A over here such that this length is 1 unit. So this point 1 A, it is basically representing 1, but we are writing the rational numbers in the form so that they should have denominator 2. So 1 we can write as 2 by 2. So we are saying this point A, it is representing 1, but we are talking about all rational numbers with denominator 2. So A is 2 by 2. Now if we mark the midpoint B of OA, we are going to mark another point over here. We are saying this length OA is the unit length. We are going to mark a point B, that is the midpoint of this OA. Then this point B, it is representing the rational number 1 by 2. This B is representing the rational number 1 by 2. Now we have obtained a fixed length. We are saying we have obtained a fixed length. Over here we are talking about this length from O to B. This length is the half unit length. Now using this fixed length OB, we are going to mark some points. So we are saying starting from this point 0 or O, we are saying we set off equal distances, each equal to the length OB, and OB length we have it is half unit. So the next point we are going to mark, it is, suppose after A I am marking a point over here, and then I have marked another point over here. Likewise, we can continue. And these points that we have marked over here, we are saying corresponding to these points, this length is OB. Then this OA length, that will be 2 times OB. This length we have, this is 3 times OB. Then this length we have, it is 4 times OB. So if this point, it is representing 1 by 2, this is representing 2 into 1 by 2, then this next point will represent 3 into 1 by 2. This next point will represent 4 into 1 by 2. So what we have done, we are saying that from the point O, on the right hand side, the points at the distance equal to OB, 2OB, 3OB, we have marked these points, and they represent the rational numbers 1 by 2, 2 by 2, 3 by 2, 4 by 2, and so on. And similarly, by using the same length, we are saying we have this length 1 by 2. Now if we mark the points on the left of OB, we are going to mark the points on the left of OB. The distance, or this length, we are saying, what this length, it is 1 by 2 length. We have marked these points at the distance 1 by 2 from each other. So what we have obtained, that from the point O, on the left hand side, now we are talking about, the points we have marked, they are at the distance OB, 2OB, 3OB, and so on. And these points, they denote respectively the rational numbers minus 1 by 2, minus 2 by 2, minus 3 by 2, minus 4 by 2, and so on. So this is how we can represent all rational numbers with the denominator 2 on the number line. Now next, we are going to prove that we can represent the rational numbers with the denominator 3 on the number line. So we proceed in the same way. We are saying that we are going to draw a line xy. We have this line we are going to draw, it is the line xy. And on this line, we take a point O on it, which represents the number 0. So we have taken a point O over here, and this point, it is representing the number 0. Next, we are going to take a fixed length OA, that is 1 unit length. We are going to mark a point, and we are saying that this is at 1 unit length. Now we are talking about the numbers with the denominator 3. So when we are talking about the natural numbers or the representation of integers, we were saying that this point A, it is representing the number 1. It is at the unit length. Now 1 can be represented as 3 by 3. When we are talking about the rational numbers with denominator 3, the equivalent form of 1 is 3 by 3. So we are saying that we can write this 1 as 3 by 3. Now we are going to divide this length OA in 3 parts. We are saying we divide OA into 3 equal parts with OC as the first part. We are going to mark a point over here and name it as C. This is basically the 1/3 of this length OA. So this point C, it represents the number 1 by 3. So we are saying this C represents the number 1 by 3. Now from this point O, we set off equal distances, each equal to OC is equal to 1 by 3 units on the both sides of this point O. And when we are moving towards the right, we are saying the points at a distance equal to OC, 2OC, 3OC, and 4OC from the point O on the right, they denote respectively the rational numbers 1 by 3, 2 by 3, 4 by 3, and 3 by 3, 4 by 3, and so on. So we are saying that we are going to mark the points at the distance 1 by 3 towards right. And what these points are representing, this OC, it is 1 by 3. The next point, that will be 2 times 1 by 3, that is 2 by 3. Then 3 times 1 by 3, it is 3 by 3. Then 4 times 1 by 3, it is 4 by 3. Then 5 times 1 by 3, it is 5 by 3. Similarly, we will mark the points at the distance OC, 2OC, 3OC, 4OC, and so on the towards the left of this number 0 or number O. And these points, they will represent the numbers. We are first marking the points over here on the left. we are using the distance we are talking about. We are using this distance OC. We have marked a point over here at the distance 1 by 3. Then we have marked a distance at the distance of this point from O. We are talking about the distance of this point from O. It is 2 times 1 by 3, that is 2 by 3 units. Then next point we are marking at the distance 1 by 3, next point. So these points that we have marked towards the left, they are representing the numbers minus 1 by 3, minus 2 by 3, minus 3 by 3, minus 4 by 3, and then minus 5 by 3. So from this we can see that we can represent every rational number with the denominator 3 on the number line. And if we continue in this way, we can see that we can represent any rational number on the number line. Now the next question we have is represent 2 whole 3 by 8 on real line. So when we are talking about this number 2 whole 3 by 8, we can write this is equal to 2 plus 3 by 8. It means if I am talking about the number line, I have first to move 2 units and then we are moving the 3 by 8 units towards the right hand side of the number 0. So how we are going to proceed is we are saying that we draw a line xy. We are going to draw a line xy and we are going to mark the points on it as we do in case of integers. We are saying that this is we have represented the integers on this line. Now we have to mark the point 2 whole 3 by 8. So 2 whole 3 by 8 we have seen over here, it is 2 plus 3 by 8. So one thing is clear that this point 2 whole 3 by 8, first of all from this point 0, if we move 1 unit towards right, we will reach the point A. Then we move another 1 unit towards right, we will reach the point B. We are saying that on the right of O, we have this length OA that is equal to 1 unit and the length OB we have that is equal to 2 units. So this first part we are talking about, this 2 units we have moved when we have reached this point B. Now what we have to do, we are going to divide the portion between B and C. The denominator over here, it is 8. We are talking about the number 3 by 8. It means we have to divide this portion between B and C in 8 parts. So we are saying we divide the portion between B and C in 8 equal parts. Now to divide this portion in 8 equal parts, we are going to mark certain points over here. How many points we are going to mark? We are going to mark 7 lines over here. So we have divided the portion between B and C in 8 parts. Now what these parts are representing, when we are talking about this first line that we have drawn, this part, first part we are saying, then when we reach this point, we have moved the distance 1 by 8. When we reach this second point, we move the distance 2 by 8. When we reach this third point, we have moved the distance 3 by 8. So this third point, we are marking it as the point P. And we are saying that this length BP we are talking about, it represents the 3 by 8 unit of the distance of a unit. This is the 3 by 8th portion of the unit distance. The unit distance we have, it is the distance between B and C is unit distance. We have divided this portion in 8 parts. This third part, when we have moved, we have crossed the third part, this point P, it is representing the 3 by 8 of a unit distance. So now what we can see over here, when we started from this point 0, we have moved 1 unit distance, we reach point A. We move 2 unit distance, we reach point B. Now we have moved 3 by 8 unit distance and we have reached this point P. So we are saying that this point P, it represents the number 2 whole 3 by 8. Next we have is represent the number minus 1 whole 5 by 7 on the real line. So if we look at this number minus 1 whole 5 by 7, we can write this is equal to minus 1 minus 5 by 7. So what this number represents, that we are moving first of all we are moving towards the left. We have to move 1 unit towards the left, then in the next interval we have to move 5 by 7 units towards the left. We are moving towards the left from the number 0. So how we are going to plot this number is, we are saying that we draw a line xy, and by taking a fixed length as unit length, we represent the integers on this line. We are talking about this case over here. We have represented the integers on this line. Now we want to represent the number -1 whole minus 5 by 7. It means first of all, this is the number 0. We are going to move the distance -1 units towards the left. Look at this portion over here. It is -1. So we are moving the distance -1 units towards the left. So this thing is mentioned over here, that on the left of O, we are moving the distance OD is equal to 1 unit. Now, after moving this distance 1, we have reached this point O. We have moved 1 unit distance. Now this number -1 whole 5 by 7, it lies between -1 and -2, and we require to move further the distance 5 by 7 units. So 5 by 7 unit means that we have to divide this portion between -2 and -1 in 7 parts. So we are going to mark 6 lines over here. We are going to mark 6 lines over here. So when we are saying this first part, when we have moved this first part, the length of this first part, it is 1 by 7 units. Then next, when we reach this point, we have moved 2 by 7 units. This point, when we talk about, we have moved 3 by 7 units, 4 by 7 units, and this point we are talking about, this line we are saying, this is representing the distance from -1 as 5 by 7 units. So we are marking this point over here. We are saying this is the point Q that we have. So to sum up the things, what we have done, we have divided the second unit DE into 7 equal parts. We have divided it in 7 equal parts, and we can see that this length DQ we have, it is 5 by 7 of a unit. This length is 5 by 7 of a unit. So what we have done, we have moved, we have started from this point 0. We are saying we have moved 1 unit length toward left, and then we have moved 5 by 7 unit length towards left. So when we look at this value, we have moved 1 unit towards left, then 5 by 7 units toward left. It means that this point Q, it represents the number -1 whole 5 by 7. Now the next case we have is, if the rational number is given in the decimal form and we want to represent it on the number line. So the first number we are considering over here, it is 3.895. So clearly this is a terminating decimal, so it is a rational number. Now we want to represent it on the number line. So we can see over here, we are talking about 3.895. If I plot the number line over here, then this number 3.895, this number will lie between 3 and 4. This will lie between 3 and 4. So we are saying, first step we are saying that 3.895, it lies between 3 and 4. So we magnify this portion between 3 and 4. We are talking about, we are going to magnify this portion between 3 and 4, and then we are going to divide it in 10 parts. We are going to divide this portion in 10 parts. So when we divide this portion between 3 and 4 in 10 parts, we obtain something like this. We are saying this is, we have magnified this portion, this point 3 is over here. We have magnified this point 4, it is over here. And we have divided this portion between 3 and 4 in 10 parts. Now look at this number, it is 3.895. So what we can see, look at the first two, 3 units we have already moved, 1, 2, 3 units we have already moved. We are talking about this portion between 3 and 4 now. We have divided this portion in 10 parts. Now where this number will lie, this will lie after 3.8 and before 3.9. So we are saying that this number, it will lie between 3.8 and 3.9. Now we are talking about this portion. We have seen that this number, it will lie between 3.8 and 3.9. Now we have to divide this portion in 10 parts. So we are going to magnify this portion over here. We are going to magnify this portion. We are saying this is the point 3.8 we have, and this is 3.9 we have, because we want to divide this portion in 10 parts. So we have magnified this portion and divided this portion in 10 parts. So now look at this number 3.895. We have, this is the number 3.89. We are saying this is 3. We have moved the distance 3 units. Then we have to move the distance 0.89. We are saying we have moved the distance 3 units. Then we have moved the distance, that is 3.8 units. It lies between 3.8 and 3.9. Now it lies between 3.89 and 3.9. We are saying this number, we are talking about 3.895. It lies between 3.89 and 3.9. So again, we have to divide this portion. First we are talking about that it lies between 3.89 and 3.9. So we are saying that we are going to divide this portion between 3.8 and 3.9 in 10 parts. We are talking about 3.89. We have divided this point. This is 3.9. We have magnified this portion, and again we have divided it in 10 parts. So what we obtain is that this given number 3.895, this is the given number. This point over here, this is the given number. So we can look at this situation in this way. We are saying that the number we are trying to locate on the number line, it is 3.895. So what we are doing in the first step, we are saying that this number, it lies between 3 and 4. So we magnify this portion. We magnify this portion between 3 and 4, and then we have marked 10 points between this portion. The number we have, it is 3.895. So we are saying this is 3 plus 0.895. It means that it lies after 3. Now look at this term. We are saying this number is 3.8. We are talking about this number is 3.8. It means we are saying 3.8 plus 0.095. We have this term. It means that it lies after 3.8 and it lies before 3.9. So we are talking about this portion. Now we have divided this portion between 3.8 and 3.9 in 10 parts. We are saying we have 3.81, 3.82, 3.83, 3.84. We have divided this portion in 10 parts. Now the number we are talking, it is 3.895. We are saying it lies after 3.8. Now further, it lies after 3.89. It lies in this region, somewhere in this region. So we further magnify this portion. We divide this portion again in the, we are talking about this portion. We are dividing this portion again in the 10 parts. We are saying this first part, when we are talking about this first line, it is representing 3.891. The next line, it is representing 3.892. Next line, it is representing 3.893. And likewise, if we continue, we will obtain that this point, it is over here. We are saying this is the point 3.895. So if we highlight this point, if we are saying that we highlight this point 3.895, we are talking about, this is the point we have marked somewhere over here. Now look at this situation. When we are zooming it out, what we can see, that we have located this point on the number line, you can see that this point we are talking over here, it lies somewhere at this point on the number line. So we are saying that this is what successive magnification is. This is what successive magnification is, that we have first considered the portion 3 by 4. We have magnified this portion, we have divided it in 10 parts, and then continuing in this way we obtain the exact location of the number 3.895 on the number line. Similarly, the next number that is given to us, it is 2.32 bar, and we have to represent it on the number line, and we have to represent it up to 4 decimal places. So when we are talking about this number, we can write it is 2.32 bar. It is 3.222 because we have to write it up to 4 decimal places. So we have deleted all the terms after 2. Basically, this is the decimal representation we are talking over here. It is the non-terminating and repeating decimal. So that is why it is a rational number. So we are saying it is of the form 2.32222 so on. But we want to represent it up to 4 decimal places. So we are writing it in this way, that it is 3.2222. This is the representation up to 4 decimal places. So what we can see is that the number lies between 2 and 3. So if we are talking about the number line, we can see that this number, it lies between 2 and 3. So the next step we have is, we are saying that this number, it lies between 2 and 3. So we magnify this portion between 2 and 3, and we obtain the value or the representation of the number line in this form. We are saying this is the point 2, this is over here. We have, this is the point 3, this is over here. We have divided this portion between 2 and 3 in 10 parts. Now this number, this will lie between 2.3 and 2.4. So we are going to magnify this portion. We are going to magnify the portion between 2.3 and 2.4. So when we magnify this portion and divide it in 10 parts, we are saying we are having the representation in this way. This is the point 2.3, this is the point 2.4, and we have divided it in 10 parts. So we are saying now this number 2.3222, it lies between 2.32 and 2.33. We are saying it lies between these 2 points, 2.32 and 2.33. Now if we magnify this portion, we are saying we are going to magnify this portion. It is 2.32, and this point, it is 2.33. We have magnified this portion and we have marked the 10 points. We have divided it in this portion in the 10 parts. So we can see that this number 2.3222, now it will lie between 2.322 and 2.323. It will lie in this portion. It means we have to divide this portion in 10 parts. So we are saying that this number, it now lies between the numbers 2.322 and 2.323. And when we divide this portion in 10 parts, we are saying this is the number 2.322. This is 2.323. We have divided it in 10 parts. We have actually divided this portion now in 10 parts. So we can see that the number we are talking over here, it is 2.322. That is over here. So this is not the representation of this given number. It is the representation of the number 2.3222 and so on. So if we have to represent this number 2.32222 so on up to infinity, then it means that this process will continue like this, and we cannot locate exactly, we cannot give or tell an exact point where this number will lie, because we will always obtain two numbers between which this number will line. So we are not considering that case. We are just restricted to the case when we are saying that we are considering this number up to 4 decimal places, and this is the representation. This point we are saying 2.3222. This is the point that represents this number up to 4 decimal places on the number line.